Alrighty, everybody. Now we have our mixed review. We are going to be fortune tellers. We are going to predict the future. And we can talk about what our different types of reactions are and literally predict what's going on. Okay, so if we want to think about our different types of reactions, look at the base word that makes them up. In a combination reaction, we are combining things together. We are making something. And that is like joining two things together. So that is like a marriage. Okay, you have two things becoming one. A decomposition is breaking things apart. That is like a divorce if you think of your types of reactions. Sorry if I bring up any bad memories of anybody, but we have our one compound that is going to break up and make something new. Single replacement is going to be the switching of one of our substances. So that is going to be like an affair. So what we have is one element that's going to try to break up a couple, one element and one compound. So you're going to see that just because something is presented with the opportunity to stray doesn't necessarily mean it's going to happen. A double replacement reaction is when you switch two things. So this is that wife swap, that double replacement reaction where you have two compounds and they are going to switch who they are with. Okay, and then combustion reactions are going to be arguments. They are going to be heated and they are going to take in a lot of oxygen and make a lot of CO2 and steam. Okay, yes, you make gaseous water. You never make liquid water. I've never, ever, ever seen anything burn and make liquid water because you are releasing energy, and that energy is immediately going to vaporize your water. Okay, so like I said, a combination is like a marriage, decomp is divorce, the affair, the swap, and the argument. And this is where you have an element, a compound, one element and one compound, two compounds, or a hydrocarbon and O2. So what I did for you is, since all of these are all different, okay, I organized this study guide for you. So it's on the website and in your notes embedded in there. And you'll see that there are the predicting the different types of reactions in your study guide. And here we go over our combination reactions, and I give you examples and putting them together with their ions. Then we have our decomposition reactions where we break up into their elements. Our single replacement reactions where you have your metal replacing another metal or your non-metal replacing another non-metal. You have to check the activity series of the metal to make sure that it is more active. The double replacement reactions are when you swap with what you're making. Two aqueous compounds either need to make a precipitate H2S or H2O. So you have to look up on the solubility table. If it's S, it's soluble, I, it's insoluble, and I give examples of each. And then down at the bottom, your combustion reactions where you have your hydrocarbons get oxygen to form CO2 and H2O no matter what. Okay, so let's walk through some examples and try to predict what is going on. Okay, so here we have PbO2. This is one compound, one whole thing that is going to be here. It is going to break up. It is going to divorce. So this is going to be a decomposition reaction. Okay, Ca plus S. I have two single elements. So that's going to be my A plus B. That is going to be my marriage. And my marriage is going to be my combination reactions. I would add at least a combination because there's COMb for combination and COMb for combustion. C5H12 plus O2. This is a compound and an element. Ooh, but be careful here. This is a hydrocarbon plus oxygen. So this is CXHY plus O2. This is going to be my argument, and this is going to be my combustion reaction. Okay, so what we're going to do is we're going to take our NaCl and K2SO4, and we're going to see that these are two compounds. And the two compounds are going to be AB and CD. They're going to wife swap. And when they wife swap, that is a double replacement reaction. I'm going to have to look at the solubility table for that one. And then lastly, we have our calcium plus Fe2O3. So this is one element and one compound. And that means it is going to be an affair, A plus BC. So I am going to see a single replacement reaction where I need to look at the activity series for this one. So you're going to have that stuff handy. So let's do exactly that, and then we'll be able to predict the future. Okay, so now that we know what they are, let's do what they say. Pb plus O2, let's break them up. I make Pb plus O. Anybody diatomic? Yeah, the O is. Okay, now is it balanced? Yepers. So we're going to leave it like that. Okay, Ca plus S, we're going to marry them together. Okay, so this is Ca2 plus S2 minus. I make CaS, gas. Is it balanced? Yes, yes it is. Okay, so this is our decomposition reaction. This one is our synthesis or combination reaction. And next we have our C5H12 plus O2. This is our combustion reaction. Do you remember what combustion reactions always make? They always make CO2 and H2O. So now I need to balance this out by putting a 5 in front of the CO2. If I have 12 hydrogens here, I need a 6 over here. 5 times 2 is 10, plus another 6 gives me 16 total oxygens on the right-hand side. So I'm going to need an 8 over there in order to balance it out. Then I have NaCl and K2SO4. Write your ions, Na plus, Cl minus, K plus. Sulfate is SO4, 2 minus. Outside things come together, inside things come together. I get Na2SO4, and I get K plus and Cl minus KCl. Ask yourself in this double replacement reaction the 3 questions. Did I make water? No. Did I make H2S gas? No. Did I make a precipitate? I don't know. Let's check the solubility table. So when you check the solubility table, all sodiums are going to be soluble, so this is an AQ. All potassiums are soluble, so this is AQ. So what does that mean? That means there is no reaction going on. I didn't make anything, okay? It's just all these ions floating around. Wait till we get to complete and ionic equations, okay? And then we have Ca plus Fe2O3. Okay, Ca makes a 2 plus, Fe2O3. When I uncrisscross them, this gets the 3 plus, O gets the 2 minus. This is a single replacement reaction. Okay, the cation is going to replace the cation. Is calcium higher on the activity series? Okay, calcium is up here, iron is underneath it. So is it stronger? Yes, it is successful. So kick out iron. He's now sad and alone. Boo-hoo. And bond the Ca2 plus to the O2 minus, and we get CaO. Is that balanced? No, I have 2s and 3s is down here. So I'm going to need a 3 up here. I'm going to need a 3 over here. And I'm going to need to balance out these 2 irons here by putting a 2 right there. Okay, so if you can't read my handwriting, here you go. Everything is all typed out for you. Here are our lovely answers. Pb plus O2 gives us CAS, or Pb and O2 are our decomposition answers. Okay, CAS is going to be our combination answers. Our combustion answers are here. Here is our double replacement, and then here is our single replacement. So you treat everything differently because everything is different. This all comes together. So if you need any help with individual questions, please go back in the playlist and see what each type of reaction is like, and then you can use that in order to predict the future. Welcome, fortune tellers.